You know, every star up there has a story, a beginning, a middle, and an end. But when that star is our own sun, well, its final chapter is also ours. So today, we're going to look at the ultimate cosmic forecast for our star and for our home planet.
So let's just dive right in with the big one, right? The question that sits at the very, very end of all human history. When does the clock finally run out for planet Earth? And what you're going to find out is the answer? It isn't just a single, simple date. To get to that answer, we've got to understand that our sun isn't just some static ball of fire in the sky. Not at all. It's a dynamic, evolving star with a past that, believe it or not, created us, and a future that will, eventually, erase us. And if we look back in time, we find this incredible puzzle that really stumped scientists for a while. 4 billion years ago, our sun was way fainter than it is today. I mean, with that little heat, the ancient Earth should have been a frozen snowball, completely solid. But we know from the rock record, it wasn't. So what gives? Well, the answer was our atmosphere. Early Earth was wrapped up in this super thick blanket of greenhouse gases. We're talking carbon dioxide levels that might have been hundreds of times higher than today. This primordial greenhouse effect trapped the faint sun's heat and kept our young world just warm enough for life to get started. Okay, and this is so important to get straight. We have to put this long-term solar warming into perspective. Yes, the sun is getting brighter over billions of years, but this natural change is incredibly, incredibly slow. It accounts for a tiny, completely unnoticeable fraction of the warming we've seen in just the last century. Today's climate change is happening at a rate 625,000 times faster than that. They're not even in the same ballpark. Now, let's look to the future, because Earth doesn't just have one appointment with destiny. It turns out our planet is facing two very distinct deadlines, both delivered by our aging star. It's like a cosmic 1-2 punch. So here's the timeline. The first deadline, that's not the end of the planet itself, but it is the end of complex life. In about 1 billion years, the sun will be 10% brighter. That's hot enough to literally boil our oceans away and sterilize the surface. The final, physical destruction comes way later, in about 7.6 billion years, when the sun itself expands and swallows the planet whole. So what exactly happens during this red giant phase? Well, the sun's core, after running out of its main fuel, hydrogen, will start to shrink and get much, much hotter. This kicks off a new phase where it starts fusing helium, and that causes its outer layers to just swell outwards, becoming this colossal glowing giant that will just gobble up Mercury and Venus, no problem. Now, for a while, some scientists thought Earth might just squeak by. See, as the sun expands, it also loses mass, which should, in theory, cause Earth's orbit to drift outwards to safety. But a really detailed study in 2008 concluded that things like tidal forces and drag from the sun's atmosphere will slow Earth down, causing its orbit to decay and spiral inwards. The verdict is in. Our fate is sealed. But you know what? The end of our solar system isn't just a story about destruction. It's also an incredible story of cosmic creation and recycling. After its red giant phase, the sun will shed its outer layers, puffing them out into space. This expanding cloud of gas gets lit up by the tiny, hot core left behind, and it forms this absolutely breathtaking structure called a planetary nebula. And here's a fun fact. Despite the name, it has nothing to do with planets. It's just what they looked like through the blurry telescopes of early astronomers. This whole process, it just perfectly illustrates one of the most profound ideas in all of science. The universe wastes nothing. The death of one star literally provides the raw materials for the next generation. These nebulae, they seed the galaxy with heavier elements like carbon and oxygen, the stuff that's essential for life. This material eventually gets mixed up and collapses to form new stars and new planets. I mean, the iron in your blood, the calcium in your bones, all of it was forged inside a star that died billions of years ago. We are, quite literally, made of stardust. So what about the sun's core, that little ember left at the heart of the nebula? Well, its story is a different one. It's a story of a slow, quiet fade into an unimaginable darkness and cold. This remnant is called a white dwarf, and it's an object of just unbelievable density. Picture this, a star's worth of mass crushed into a sphere the size of our planet. It's not generating any new heat. It just sits there, slowly radiating away its leftover warmth over eons. The theoretical end of the line for this thing is a black dwarf, a cold, dead stellar remnant that gives off no light or heat. But here's the really wild part. The time it takes for a white dwarf to cool down is so ridiculously long that not a single black dwarf is thought to exist anywhere in our 13.8 billion-year-old universe. Not one. We are talking about timescales that just dwarf the current age of the entire cosmos. Trillions of years for our sun to finally go cold and dark. It's a length of time so vast, it's almost completely meaningless to the human mind. So when you're faced with an end that definitive, it's only natural to wonder, could a civilization that's advanced enough actually change its destiny? Could we, in the distant future, figure out a way to escape? Well, one of the more modest proposals is to literally move our entire planet. The idea is to carefully steer some big asteroids past Earth, using their gravity over and over again to gradually nudge our world into a higher, safer orbit, outrunning the expanding sun, at least for a while. It's an incredible thought, right? But hey, why stop there? Why just move the planet when maybe, just maybe, you could move the star itself? This leads us to the concept of a stellar engine, and specifically something called a Shkotov thruster. We're talking about a hypothetical megastructure on a truly epic scale. Basically, a giant mirror built to move an entire star system across the galaxy. And the physics behind it is surprisingly kind of simple. Sunlight itself actually exerts a tiny physical push. It's called radiation pressure. So if you build a massive mirror to reflect a bunch of that light in one direction, you create an imbalance. This generates a very small but constant push that over millions of years could propel our sun and all its planets to a brand new home. And this isn't just some sci-fi daydream. Astronomers who are searching for extraterrestrial intelligence, the SETI folks, are actually looking for things like this. A star that's moving strangely, against the galactic flow, could be what they call a technosignature. Hard evidence of a civilization so advanced, it can literally pilot its own sun.
And that really brings us to our final thought. The fate of our sun and Earth seems like it's set in stone by the laws of physics. But the future is a very, very long time, and technology that seems completely impossible to us now might one day be, well, commonplace. It really leaves you wondering, if a civilization can learn to move stars, what other limits are there to break?